Hello, my name is Evan Hamaoka, and welcome to a series about AP Computer Science A for YouthSTEM. This is our second video in the series, and today's lesson will be about strings, math, and logic here comprises booleans and conditionals especially. This will be the most mathematical and technical video in the series, I think, but if you like logic puzzles and games, this video will be for you. First, the string. What are strings? The string is another important data type in Java. A string can store characters, words, and even sentences. Strings are not a primitive data type. They're not like ints, doubles, or booleans and such, and they're immutable, meaning that once a string is created, it can't be changed. When instantiating a string, the S in string will always be capitalized like this. So string, so remember the format, data type, name equals declaration, semicolon. So string silk equals spider web. It's a string named silk, and it holds the text spider web with a space in between. And so the first character in any string is at spot 0. The first character, and this is S is at spot 0. Spaces are also counted as spots, as you can see in spot 6. Like there's a space between R and W, but it's still stored in there. There will only be one character at every spot in a string. And also, if you want to print a string, just do system to the interface. You do system.out.print silk. Silk is the name of the string. You just print it with the name of the string. So you can do it like, just system. Oh, wait, so string silk equals spider web, and then if we want to print that to the interface, print silk, and it has to just be the right name with the same case and everything. All right, spider web. And also, strings do not all have to have all numbers or all letters. It just matters that there's one character at every spot in the string. And so if we want to do something like this, string mixed up equals A1, B2, C3, D4, E5, we can, as long as it fits like as long as we have a semicolon at the end. So if we wanted to do that, we could just do string mixed up equals A1, B2, C3, D4, E5. And it's perfectly okay to print. Just to prove it to you. There. Alright, now into string methods. Strings have numerous methods, and all these string methods are part of the java.lang package, which means they're automatically imported. In later videos, like such as the one about arrays, we will import some methods like java.util.arrays, but for now, we just know that these methods that follow this heading are just they're going to be there anyway. You don't have to do anything special. So remember from the last video that a Java method performs a specific task when called. And so if we're working with, we can work with the same string. So string silk equals spider web. The method .length, close parentheses, returns the length of a string. And so if we're going to do that for silk, we do system.out.print silk. We follow the name of the string with dot length, and we need close parentheses there and a semicolon after everything. And so how long is that string? And so it has 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Even if the spot number only goes up to 9, we add 1 because it has a 0 at the beginning, as all strings do. And so this should print 10. There are 10 spots in string silk. There we go. Okay, in string concatenation, I don't really know how to say it, but this forms a new string that is a combination of multiple strings. You just need a plus between the two. For example, if we're working with the same string silk equals spiderweb, string mixed up equals A1, B2, C3, D4, E5, we can print out system.out.print silk plus mixed up, and then they just need to be inside parentheses, as the print function does. And if we do that, it'll like kind of mash the strings together. It's I don't know. This is a concept that's used a lot on the AP. Silk plus mixed up. The plus sign is not a mathematical plus. It just adds them like in conjunction with each other. And so you see this, it's kind of messy in the middle. And so if we want it, like see there's no spacing between the B of spiderweb and the A of mixed up. And so if we want to have a space in the middle, we do a nice little trick like this. So we add like just a blank space in between manually by putting it between quotes. This is technically another string. We don't really count it as such though. It's just like, or I don't really count it as such, but it's technically another string that's wedged between these two. And so we're really like adding 3 strings together, but one of them has nothing in it. So it'll create a gap in the middle like that. There we go. And so another string method that we use a lot in the AP is index of. This basically checks if a character or string is within the string that we're looking at and returns its location if it is. And it can take in a string or a character as a parameter. And so if we're going to take in a character for the first one, so we could do, I don't know, it's the same print function every time. I should just copy and paste it. All right, so if we're doing that, silk dot index of, what's the character in silk? D is in silk, so, sorry, D is in the sentence spider web. And so if we'll see what spot is D at, and so it's at spot 0, 1, 2, 3. D is at spot 3, and so it'll take the index of D within silk, which holds the data spider web, and return it's at spot 3. It'll just return 3 as a number. All right, there we go. And so we can also do this with strings, little strings within strings. We call this substrings. We'll get to that in just a minute. But we can I'm working through this a lot because this appears in the AP very frequently. We have to put it in quotes again. So I don't know, what's a string within spiderweb? Piter, yeah. And so where do we find? We first find if we find the first character in Piter at say spot 0 and spot 1. P is a character in Piter. There, and it's found at spot 1, and so it'll return 1 because it finds it at spot 1 first. There we go. And then so if we use index of and we don't find the character or string inside if we don't find the character or substring inside of the original string, I don't know what's not in spiderweb. Q. Yeah, there's no Q in there. What? Oh, I need an end quote. Yeah, but if we don't find Q in there, which we won't, it'll signify that to us by returning the value -1, which basically just says, yeah, it's not in there. All right, so for more string methods in Java, char@x returns the character, or .char@x more specifically, returns the character at spot x, and x must be a number that has a corresponding character in the string. So we can run that again with silk, and so do system. Okay, I haven't copied and pasted. All right, there we go. That silk.char@, and the a and at has to be capitalized. And note that it already basically fills it for you. So if we do silk.char@0, we need the 0 in parentheses as well. This will see what's at spot 0. We already established that. S, and so it will print S, and then so. But this has to be a character within the amount of characters in the string. So if we wanted to do silk, see what's at spot 32. There won't be anything at spot 32 because silk or spiderweb doesn't have a spot 32, and so it'll have an exception error here, string index out of bounds, and we can't do that. So yeah. And we have some more methods here, like substring, which is this is pretty important, especially for the AP problem. And so substring will return a section of a string from spot x to the end of the string. And so if we're gonna do something like, there's a lot of weird caveats to this one, so bear with me. So system.out.println silk, we need to name this string .substring, and it needs to take in either 1 or 2 integers here. If we take in 1 integer, like 7, I don't know, it'll take it. This implies to this interface that we start this substring, this smaller string made of the bigger string at spot 7, and then it ends at the end. Oh yeah, see, here's little dude. It just appeared. Okay. Anyway, so what's at spot 7? Spot 7, 0, 1, 2, 3, 4, 5, 6, 7. So spot 7 is at W, and so it'll return from W to the end of the string, which will print out web. There we go. But there's a really weird caveat to substrings that you really have to know for the AP. So if we're gonna have 2 bounds in this substring, such as on my example, I've if we're going to do silk.substring 1, 5, you'd expect it to return Piter, right? So P is at 1, and then R is at 5, so P-I-D-E-R. However, it'll actually return the section of the string from character 1 to character 4, because every time you do substring x, y, or 1 to 5, whatever, returns a section of the string from spot x to spot y, not including y, and so it goes only from 1 to 4, which is pied, because x is set to 1, so it starts at 1, y is set to 5, and the substring stops 1 character before 5. It's an odd rule, but so it's one you definitely have to know for the AP. Pied. See? And there are some lesser known methods that like you probably should know. They're useful. They're not necessarily super common. Like is uppercase returns a boolean true or false based on if the character at spot X is uppercase, and is lowercase returns a boolean based on if the character at spot X is lowercase. And like I have some examples here. You can test them with Silk if you want on your own, but I'm not going to really run through them because they're not super not super used in this course. Is digit is kind of a similar thing. It returns a boolean based on if the character is a digit, and so if we're doing character is digit, we need this at the beginning of the character dot is digit, so dot char at 1, that will return false because we find the letter P in spot 1 and P is not a digit. All right, now into the second part of our video, math in Java. Math in Java has the same four main operations as the math you learn in school, and to not get super technical, basic Java math follows PEMDAS, so parentheses and exponents come first, then multiplication or division depending on what comes first, left to right, and then addition or subtraction depending on which comes first, left to right. And so if we have int x equals 12, int y equals 3, we declare these as variables, and if we apply like math operations to each one, the results will be what you expect. It's just like doing normal. It's just like doing 12 plus 3 and just on paper or whatever. Nothing's really different, and I'll prove that here. And then it'll x plus y is 12 plus 3, 15, x minus y. 12 minus 3 is 9. And we need the star here for multiplication. It's just, it can't be like an x because, you know, x is a variable. And then we need a slash here for division. But then it's just like, it runs as you would normal math. It's not anything super complicated. However, there are two things though. First, remember that the integer type can only store whole numbers, and so if we're dealing with an expression that will yield a number with a decimal to end, like if y was actually 5 or something, we were doing this, what do you think it'll print? Well, the real answer, if you did it on paper and stuff, would be 2.4, but like 2.4 is a double, and we're working with ints. The output has to be an int because we're doing operations with two ints. And so that's called truncation. What it does, it'll cut off like the last decimal bit of it, and so that'll eventually just print. It'll just print 2 because the 0.4 is chopped off to become an int. It'll always round down, even if it's like 2.999. However, we can do the same equation and get 2.4 one of two ways. Like we can set both x and y equal to doubles originally, and then carry out the equation. Like just like the variable type can be changed just for the sake of ease. 2.4. Or alternatively, we can do what's called casting, and then even if we're working with integers, you can do system.print double. You have to put the word double, lowercase, in parentheses before the variable, and then double parentheses before the next variable. And so both of these will print 4. Okay, so we gotta reset the value. Sorry, both of these will print 2.4. They'll print the 0.4. I'm sorry. All right. So then we have double, and then double. This is called casting, as the slides say. There we go. And we can even test it with just one of them, even just one of them having a double, and it will print the same thing. If double divided by int is still a double, and that works as 2.4. It's pretty cool. And so basically casting your brute forces the variable following the word double in parentheses to become a double and yield a non-integer answer while dividing. The value of the number does not change though. 12 just becomes 12.0. Oh yeah, and also print functions can accept math arguments as well, as we've just seen. For example, like even if you put the raw numbers in there, doing system.print 7 plus 8 will yield 15. We can do that here, just system.print 7 plus 8. As long as you have the numbers there properly, then it will print out 15. But what do you think that this will print out? System.out.println 7 plus quote, so blank space, plus 8 plus 9 prints. It will be really tempting to say that it prints 7 and 17 with a space in the middle. However, we can actually run that. We need to put the space in the middle. Oh, we need 7 plus the space, plus 8 plus 9. It will print 7, 8, 9. Why? That seems pretty weird. Because the addition of a string, even though the blank space is nothing in it, it's technically a string and holds a quote unquote character that holds nothing. But then that turns the remainder of the print statement into a string. And so this is, again, consubstantiation as we had before. So it has 7 as an end, but then it has plus string, and then 8 plus 9 are added to each other. It's not 89. They're added to each other like just as part of a string. It's pretty interesting. All right, now onto a Java math practice problem. So if we have int a equals 11, int b equals 4, double x equals 11, and double y equals 4, we print line a divided by b, we print x divided by y, and we print a divided by y. And so there will be 3 numbers printed here, but what will be printed as a result of executing the whole code segment? Think about it for a second. All right, we can test it, but I'll walk through the steps in the way. So if we've int a equals 11, int b equals 4, they all need to be instantiated, like properly, obviously. And double y equals 4. And also note these are, even though it says 11, these, if we printed out like x right now, they would actually be 11.0 and 4.0 respectively. So anyway, also then system dot out dot print ln a divided by b. All right, just copying that and just doing the proper functions inside. Just doing this to show the syntax properly. Okay, and there we go. So for the first math problem in this line, we see that it divides a by b. Both a and b in this problem are integers, so the result, it'll be 11 divided by 4. And in reality, that's a decimal. It will be truncated to an int. So 11 divided by 4 is actually 2.75, but that's truncated to 2. So the first line will print 2. And so for the second line, for the second math problem, you divide x by y, which is 11 divided by 4. These variables, however, are both doubles, and so the result will also be a double, and you'll get the right answer. You'll get 2.75, and there's no error from truncation in that because you don't have to truncate. And for the third problem, you divide 11 by 4 again, but then this one has, like, the variable that holds 11 here is an integer, and the variable that holds 4 is a double. But according to the AP comp sci book I have and the comp sci rules, if one of the operands is a double and the other is an integer, the integer is automatically cast to a double, and the result of the operation is a double. And so again, we get 2.75. We can run that to prove. There we go. All right, now into the third part of our video, if statements in Java. And so all if statements are written in the syntax. If condition is true, this is the abstract form, parenthesis, or bracket, statement, colon, bracket. And so the condition must be true for this to be executed. If it's not, it just won't run. And then there's no maybe statement or middle ground. It's either it's a Boolean answer. If yes, then this runs. If no, nothing. Secondly, the statement in red will only be executed if the first condition is evaluated as true. I already said that. As an example, we can establish one here. So we've int qua equals 3. We need a semicolon to declare it. If qua is greater than 2, we don't need a semicolon here. In system dot print ln, we have met the condition. So we can evaluate that as doing like, qua is 3. If 3 is bigger than 2, and so therefore we print out the statement here. And also, the word else is pretty important here. So, for example, we have the same one here. So, 3 is greater than 2, so we print this one. And then we have a second condition here later after it. It's independent of this one, but it uses the same variable. So, we have if qua is greater than 5, we have met the second condition. But then afterward, we can add the word else. And so, if this is not if this is evaluated as no, it doesn't meet the condition, and false, else, we execute the code that lies after else, which in this case is a print statement for the phrase we have not met the second condition, sadly. And so when executing this, the first one will be evaluated as true, the second will be evaluated as false, and so therefore we'll go to the code after the else statement as seen here. Yeah, like since 3 is not bigger than 5. All right, and if we want to add a little bit more complexity to our if statements, we use our 4 Boolean operators. And so for the first one, I'm going to work through some examples in Eclipse in a little bit, in 2 seconds. But for example, double ampersand means and so you put it between your 2 truth statements or whatever inside the if statement. So that would be like A ampersand ampersand B. And so to evaluate a statement like that as true, both A and B must be true. And if you read the first statement and it's not true, you don't have to read the second one to know that the overall statement will evaluate as false. That seems pretty abstract right now, but let's go into Eclipse and test it. And so For example, I set up some booleans here. So boolean red equals true, boolean orange also equals true, and boolean green is false. And so if we evaluate the if statement, we evaluate the if statement. This is our checking condition. If red and orange, this is basically just evaluating. If red is true and orange is true, these are both true, we print out the painting is red and orange. And as you can see, red and orange are true, and so this will execute. Our next one is the or statement, and it's notated like this, and then it's also in Eclipse here with this statement. So basically, with the or statement, to evaluate A or B as true, it's like in real life, at least one of the conditions must be true. Either A is true or B is true, or both are true. That works too. It just can't be that none of them are true. So if you read the first statement and it's not true, you have to read the second one to evaluate with the overall statement. If you read the first statement and it's true, you don't even have to read the second statement. So we can go to Eclipse and test something like that. So if orange is true or green is true, we print out the painting is orange or green. So this one, if or is orange true, orange is indeed true, and so we don't have to check the second one. I mean, the green is false, but that doesn't matter because at least one of them is true. Like if we, and so we can print that out, and we'll print it out in a second, just with everything. Our third operator is double equal sign, which means is equal to. Note the two equal signs, 1, 2, is operator is often used on strings. And so we could do something like that, especially with string comparison. And so we have down here string name 1 equals Josh Hutcherson, string name 2 equals Josh Hutcherson, and these are the same string. Basically, these are the same string. They have the same data in the same location. J at spot 0, and then O at spot 1. Continuing same spacing and everything. And so we can do an if check on this one. If name 1 equals name 2, which they do, they're the same thing. We print out the names match, and so we can run all these, and they all print because it is red and orange. Red and orange are true. Orange is true, and that's all that counts. And then these match. And then the last Boolean operator is an exclamation mark placed before something, which means not. And there's a certain caveat here. So, for example, exclamation mark single equal sign means not equal to. Like this is a pretty important caveat. Like for example, if we wanted to have like if name 1 doesn't equal name 2, we can't do this. This will evaluate with an error, and so we have to delete this token here. And so we can run all this again, and so this is saying if name 1 is not the same as name 2, we print the names match. We can print the names. Yeah, then we can print out the names match for sure, but it doesn't print because these are the same. But if we're going to like make these any different, for example, like if we're excited about name 2 being Josh Hutcherson, and then if name 1 doesn't equal name 2, now we have this. We print the names don't match. They don't match because of the difference in characters, and this is significantly longer, and there's exclamation points in some spots, whereas this one doesn't. So if we print that, the third one will evaluate as true. The fact that these don't match will evaluate as true, and therefore execute the code underneath. Hope that makes sense to you. Alright, and that concludes video number 2 of our comp sci course. Thank you. And video number 3 is on loops, and video 4 is on arrays, and I hope you check those out as well. Thank you.